Welcome back to Algebra 2. We are going to start now with the 3.0 learning targets. Target 6.3.1 says to solve a rational equation while determining extraneous solutions. So in the 2.0 level target, we simplified rational expressions. So adding, subtracting, multiplying, and dividing terms that had a variable in the denominator. Now we are going to solve rational equations. So we are going to be taking these expressions and putting them in with an equal sign and figuring out what is the value of x. What is x equal to? Now this learning target says to do this while determining extraneous solutions. So first things first, what is an extraneous solution? And you've got a little definition here. Extraneous solutions work mathematically when you solve the equation, but they are not true solutions because the equation becomes false when you substitute for x. This is often the result of dividing by 0. So extraneous solutions, it kind of sounds like an extra solution. These are answers that you get when you do out all the math, but they don't actually work when you plug them back into the original equation. So anytime you're solving a rational equation, you need to double check that your answers are actually true results. And the way that we do that is we plug them back into the original equation and see whether the answer comes out to be true. So in this first example, imagine you've done all the work already. You know that x minus 24 over x equals 2 has solutions of x equals 6 and x equals negative 4. We need to double check whether these solutions actually work. So if I plug in x equals 6, that would give me 6 minus 24 over 6 is equal to 2. So 24 divided by 6 is 4. So this would be the same thing as 6 minus 4 equals 2. And 6 minus 4 is 2. So we end up with 2 equals 2. That is a true equation. So when you plug it in and you get something that is true, it works out. This is a real solution. And then we do the same thing for x is negative 4. If I plug in negative 4, minus 24 over negative 4, that's supposed to equal 2. Let's see if it actually does. Negative 4, and then negative 24 divided by 4 becomes positive 6. So negative 4 plus 6, does that equal 2? Yes, it does. Negative 4 plus 6 is 2. 2 equals 2 is a true equation. So x equals negative 4 would be a real solution as well. So on your homework problems or on your FA, you'll have 2 answer blanks typically, one for the real solutions and one for the extraneous ones. So on this particular problem, you would put down both real solutions, so x equals 6, comma, x equals negative 4. And for extraneous solutions, you would just put down none, because both of those possibilities checked out in the original problem. Now the second equation here, negative 2x over x plus 2 plus, this is a typo. So go ahead and correct your notes quickly here. It's supposed to be 3 over x, not x over 3. So plus 3 over x equal to 4 over x plus 2. This equation supposedly has solutions of x equals 6 and x equals negative 2. So we're going to follow the same procedure and see whether it actually works out. So if I plug in x equals 6, so then I'd have negative 2x, negative 2 times 6 over x plus 2, so 6 plus 2, plus 3 over x, so 3 over 6, and that is supposed to equal 4 over x plus 2. In other words, 4 over 6 plus 2. And now if we simplify this out, negative 2 times 6 is negative 12 over 6 plus 2 is 8 plus 3 over 6. We can simplify that while we're at it. 3 over 6 is the same as 1/2, and that is supposed to equal 4 over 6 plus 2, 4 over 8. So 12 over 8 That simplifies because both are divisible by 4. 12 over 8 is the same as negative 3 halves. So we've got negative 3 halves plus 1 half, and that's supposed to equal 4 over 8. Or we can simplify that as well. 4 over 8 is the same as 1 half. So does that add up? Negative 3 halves plus 1 half. That's going to equal negative 2 halves. So does that equal 1 half? No, it doesn't. So if it does not check out, the two sides of the equation are not equal to each other, that tells us that this is an extraneous solution, an extra solution that's not really real. Now if I plug in x equal to negative 2, let's see what happens there. Then I'd have negative 2 times negative 2 divided by negative 2 plus 2 plus 3 over x, 3 over negative 2, and that's supposed to equal 4 over negative 2 plus 2. So as I go along and I'm simplifying this, negative 2 times negative 2 will become positive 4. Negative 2 plus 2 is 0. Oopsies. 4 over 0 is not a real number. That is an undefined value. So as soon as you're going along, if you see that you end up dividing by 0, that tells you immediately that this is an extraneous solution. So in this problem, we had two possibilities. Neither of them actually checked out. So the real solution set, there are none. The extraneous solutions would be both the x equals 6 and the x equals negative 2. So that is kind of the final step of the problem solving process. Once you get your solutions, you do need to check out whether they actually work in the equation. But now let's move ahead and fully solve some problems to make sure that we know this entire 3.0 target. This is going to be a 5-step process, where step 5 we already talked about would be to check for extraneous solutions. But let's go back to the beginning and see how would we solve one of these problems from A to Z. So something like x minus 18 over x equals 3. Step 1 is going to be similar to just simplifying. It's going to be to find common denominators. So find an LCD, a least common denominator, so that we can add up these fractions and start simplifying. So right now I've got x. X is not a fraction, but I can write it as a fraction, x over 1. Same thing with 3. 3 is not a fraction, but I can make it into 1, 3 over 1. So looking at these denominators, I've got 1's and I've got an x. So I need all the denominators to be the same. That means 2 of these are missing the x. So I'm going to multiply by x over x. And over here, I'm also going to multiply by x over x. Multiplying by whatever I need to make sure that all the denominators are the same. And when I do that, I've got some multiplication to do here. X times x is x squared over 1x minus 18 over x. And that's equal to 3 times x, so 3x over 1x. So you see now that we have found common denominators. Everything now is over the same expression or variable, in this case, the variable x. Step 2 is the same as your 2.0 target. You want to add or subtract. So in this problem, we have x squared minus 18. Oh, both are over x. We've got the same denominator, so we can simplify that addition and subtraction. Now those are not like terms, so we're just going to write it as one big fraction, x squared over minus 18 over that common denominator of x. and that's going to be equal to 3x divided by x. So the goal thus far is to combine everything into just one term on each side of the equation. So instead of having multiple fractions all over the place, instead of having this x minus 18 over x nonsense, now we have just one term on each side. So step 3 is going to be to cross multiply. So we're going to multiply each of these fractions by the opposite denominator. And it just so happens that those are the same. So I'm going to multiply by x on the right. I'm going to multiply by x on the left. And those x's will all cancel each other out. So once I have cross multiplied, I'm left with x squared minus 18 is equal to 3x. And then step 4 is going to be to solve for x. And this is where your algebra problem solving skills come into play. This is a quadratic equation. So we worked on these in Priority Standard 2. We want to make sure that the whole thing is set equal to 0. So I would subtract 3x from both sides of the equation, get x squared minus 3x minus 18 equals 0, and then factor what multiplies to negative 18 and adds to negative 3. That's going to be 6 and 3, x minus 6 and x plus 3. And now don't forget to flip. If those are your factors, then your solutions are going to be a positive 6 or a negative 3. So step 1, find common denominators. Step 2, add or subtract. Step 3, cross multiply. Step 4, solve for x. And now we must go back to the very beginning and do step 5, check for extraneous solutions. So going back to my very starting equation, x minus 18 over x is equal to 3. So we'll plug in 6. 6 minus 18 over 6 is supposed to equal 3. Well, 18 over 6 is 3, so 6 minus 3 equals 3. Yes, that is a true equation. 6 minus 3 does equal 3. So x equals 6 is real. Let's try plugging in x is negative 3. Then we've got negative 3 minus 18 over negative 3. And that's supposed to equal the value 3. So this would be negative 3. Negative 18 divided by negative 3 will become positive 6. Negative 3 plus 6, does that equal 3? Yes, it does. So both of these check out as being real solutions. So your solution set would be x is equal to 6 and x is equal to negative 3. And the extraneous solutions would be none in this case. Let's look at a couple more examples here. Again, the first step is always going to be to find common denominators. So here I have x over 1 and a negative 7 over 1. So I want all of these to have the same denominator as each other. So all of them need that x in there. The 12 already has the x. So here I need to multiply by x over x. And over here, I'm going to multiply by x over x. So finding common denominators, now let's multiply this out so that everything is simplified. X times x is x squared over x times 1, so just 1x. This middle term didn't need to change at all. It already had x as the denominator. And this is going to be equal to negative 7 times x over 1 times x. So that's step 1, find common denominators. Step 2 is going to be to add or subtract. So on the left-hand side of the equation here, I'm going to simplify this addition problem all into one big fraction. X squared and 12 are not like terms, so I won't combine those, but I will put it all over the common denominator of x. That's equal to negative 7x over x. Step 3 is to cross multiply. So each fraction gets multiplied by the opposite denominator. So I'm multiplying by x on the right, and because this denominator is also x, I'm multiplying by that on the left. X on top, x on bottom, x on bottom, x on top. All the x's there cancel out quite handily. And I'm left with x squared plus 12 equal to negative 7x. And again, this is a quadratic that you should know how to solve. First, set it equal to 0. So we're going to add the 7x to both sides and get x squared plus 7x plus 12 equals 0. Then we will factor that. Ask yourself what multiplies to 12 and adds to 7. So that's going to be a 3 and a 4, all positive. So x plus 3 times x plus 4 equals 0. That means that x is either negative 3 or negative 4. And then we need to double check, going back to my first original problem, x plus 12 over x equal to negative 7. And we'll plug these in and make sure that they are actually real solutions. So we'll start with negative 3. Negative 3 plus 12 over negative 3 is supposed to equal negative 7. So that's negative 3 plus 12 divided by negative 3 is negative 4. Negative 3 plus negative 4 equals negative 7. Yes, it does. That is true. So x equals negative 3 is a real solution. If I plug in negative 4 plus 12 over negative 4, that's the same, supposed to equal negative 7. That's going to be negative 4 plus negative 3. So yes, that checks out as well. Negative 4 plus negative 3 is negative 7. So those are both real solutions, nothing extraneous in this case. And I will do one more example here before leaving you the last box to try on your own. I've got x plus 15 over x is equal to 8. Step 1 is to find common denominators. Well, two of these terms don't have any denominator right now, so you could think of those as being put over 1. So I've got 1's and x's. I want everything to have at least an x in there. So I'm going to multiply the ones that are missing the x by x over x. Same thing here on the right. That doesn't have an x, so I'll multiply in an x. And then if I simplify the multiplication, x times x is x squared over x times 1 plus the 15 over x doesn't need to change at all. And that's equal to 8 times x, so 8x over 1 times x, which is x. So now we will simplify any addition or subtraction. We have that right there. So x squared plus 15, those are not like terms, but we can still write them as one big happy fraction over x, and that's equal to 8x over x. So find common denominators, simplify your addition. Now let's cross multiply. We've got a denominator of x that we will multiply up here on the left, denominator of x that we multiply up here on the right. And now because we have the same thing top and bottom, that all cancels out. And we are left with x squared plus 15 equal to 8x. Step 4 is going to be to solve that little equation. So I want to make sure the quadratic equals 0. So I'm going to subtract the 8x from both sides, get x squared minus 8x plus 15 equals 0. We want to factor that, and we need two numbers that multiply to something positive but add to something negative. That means they're both going to need to be negative. So my factors would be a negative 5 and a negative 3. Negative 5 times negative 3 becomes positive 15. And if you add them together, you get negative 8. So that means my solutions are 5 and 3. Don't forget to factor and then flip. And let's plug these back into the original problem. x plus 15 over x is equal to 8. So that would be 5 plus 15 over 5 equals 8. And yep, that checks out because 15 over 5 is 3. 5 plus 3 equals 8. Yes, it does. Real solution. And positive 3. Let's try that one out. 3 plus 15 over 3 equals 8. 15 over 3 is 5. So 3 plus 5 equals 8. Yes, it does. That one is also a real solution. So it is possible that both solutions are real, not too many are extraneous, but we are only on the first half of this learning target. So to finish off for today, go ahead and try box 4 on your own. See if you can get the same solutions as me, and then hit play to see whether or not you are correct. And here are your solutions for these last two problems. For problem number 3, I got solutions of x equal to 6 and x equals to negative 2, both real. And for problem number 4, I got solutions of x equals 10 and x equals negative 2, both real. So if you got those same answers as me, then you are ready to get started on today's homework. If not, stick around for these answer explanations. So looking at problem 3, I see that the 12 has a denominator of x. The other two terms, the x and the 4, are only divided by 1. So in order to get common denominators, I need everything to have a denominator of x. So I'm going to multiply the x by x over x, and I'm going to multiply the 4 by x over x. And when I do that, I get x times x is x squared, and I get 4x. So we've got x squared over x minus 12 over x equal to 4 over x. From there, you can simplify the subtraction. X squared minus 12 can become all one term, all one fraction with the denominator of x. From there, cross multiplying, I multiply each side by the opposite denominator, which all happens to be the same. So those x's cancel each other out. And I'm left with x squared minus 12 equal to 4x. Subtracting 4x on both sides gives me x squared minus 4x minus 12. Factoring that gives us x minus 6 and x plus 2. And then flipping the factors to get the final solutions, we got x equals 6 and x equals negative 2. Up here in green and in blue, you can see where I have plugged in those numbers back to the original equation, plugging in x equals 6 and x equals negative 2. And both of them end up giving true equations, so they are both real solutions. For problem 4, let's use the same kind of approach. I noticed that the negative 20 has a denominator of x. The other two terms, the x and the 8, have a denominator of 1. So in order to get everything with the same denominator, I'm going to multiply the x by x over x, and I'm going to multiply the 8 by x over x. And when we do that, the negative 20 over x doesn't change, but x times x gives me x squared, and 8 times x gives me 8x. Then I can combine the addition of these two fractions. So negative 20 over x plus x squared over x. Those have the same denominator now, so we can combine the tops, negative 20 plus x squared, all over the common denominator of x. From there, cross multiplying to cancel out the denominators, we are left with negative 20 plus x squared equal to 8x. We want to solve that, so I'm going to subtract 8x from both sides and write it in standard form, x squared minus 8x minus 20. And then factor, seeing what multiplies to negative 20 and adds to negative 8. It gives me factors of negative 10 and positive 2, and therefore the final solutions are positive 10 and negative 2. And both of those check out when you plug them back into the original equation, so we have two real solutions. Now, some of you might be wondering, what's the big deal about checking for extraneous solutions? It seems like they both work out every single time. And that is true for most of the problems in today's lesson. But when we get into some more complicated examples on this learning target, it won't always be true. So you'll always have to check.